In part 3 of the first lecture, we are going to look at bits, bytes, and other terms that we use to measure the amount of data that we're working with. All of the data that we work with is encoded as bits and stored as a collection of bits. Typically, we store 8 bits together with its own unique numerical address. These grouping of 8 bits are called bytes. The word byte is spelled with a Y and not an I to make it easier to distinguish from the word bit. Both terms are used to describe both storage capacity and network access speeds. We abbreviate bit with a lowercase b and byte with an uppercase b. How many inches do you travel from home to campus? I ask this when I teach this class in person, and I always get strange looks. No one knows how to answer because inches are too small a unit to use when the distance is about 8 miles. We could do the math and find that it's about 500,000 inches, but it makes no sense to think of it that way. The same reasoning applies when we are measuring the amount of memory that our computer has. Using kilobytes, megabytes, gigabytes, and terabytes makes much more sense. Kilo means 1,000. But a kilobyte isn't 1,000 bytes, it's 1,024 bytes, which is 2 to the 10th power. It's important to remember that in computer science, we like to work with powers of 2. Similarly, a megabyte is 1,024 kilobytes, or 1,048,576 bytes. A gigabyte is 1,024 megabytes, and a terabyte is 1,024 gigabytes. It's easiest to remember that a kilobyte is a little bit more than 1,000 bytes. A megabyte is a bit more than 1,000,000 bytes. A gigabyte is about 1,000,000,000 bytes, and a terabyte is approximately 1,000,000,000,000 bytes. In networking, we frequently talk about access speeds in terms of bits per second. So we will also talk about kilobits per second and megabits per second, which are a bit more than 1,000 bits per second and 1,000,000 bits per second, respectively. We seem to be using the terms bits and bytes almost interchangeably. Here are a few things to keep in mind. A byte is 8 bits. We measure data rates in bits per second or kilobits per second or megabits per second. We measure file size and storage capacity in bytes or kilobytes, megabytes, gigabytes, or terabytes. It always seems that files are too large to store on the medium that we want to use, and it takes too long to transmit them, so we are always looking to compress them. Data compression means that we are going to change the file so that it contains fewer bits, but most importantly, we can reconvert it back to its original form when we need that. Compressing data is commonly called zipping. Compression can be lossy or lossless. Lossless compression means that when we decompress it, we can actually restore it completely to its original format. Lossy compression means that there is data that is actually discarded. It might be sounds outside human hearing range or visual details that our eyes can't grasp, but in either case, we will not be able to rebuild all of the original data. The software that we use to compress data is referred to as a compression utility or a zip tool. On many computers, it can be accessed from the same screen that we use to manage our files. When we reconstitute our files from the compressed version, this is called extracting or unzipping. The compressed version of our files usually end with file name extensions such as zip, gz, pkg, or tar.